Okay, so we're going to have a look at a 7-mark titration question. So let's just read through all of the text before we even, focus on what we're actually being asked. So a student does an experiment to determine the percentage by mass of sodium chlorate 1. And then they give us the formula. The fact they've given us the formula is they don't do that without reason in a sample of bleach solution. So we've got to work out what percentage of our sample bleach solution is NaClO, or sodium chlorate 1. So method, okay. So they dilute a 10 centimeter cubed sample of bleach solution to 100 centimeters cubed with distilled water. So first things first, one of the things that we can say is that we have Y moles in our 10 centimeter cubed sample, and then when we've added the distilled water, we still have Y moles. So yeah, we've diluted it. We would have a different concentration because we've got a different volume, but we've still got the same number of moles. So then they transfer 25 centimeters cubed of this diluted solution to a conical flask and acidify using sulfuric acid. Now, the transferring 25 centimeters cubed of the 100 centimeters cubed means that in this sample, we now have Y over 4 moles. We have a quarter of the original moles. I'm just using the letters Y just to, try and keep track of things. Then add excess potassium iodide to the conical solution to form a brown solution containing iodine. And then add 0.1 moles per decimeter cubed sodium thiosulfate to the conical flask from a burette until the brown solution containing I2 aqueous becomes a colourless solution containing I-. The student uses 33.5 centimeters cubed of sodium thiosulfate. So one of the things I'm going to do is they have given us a concentration and a volume of the sodium thiosulfate solution. So those two numbers are going to be important. And then the density of the original bleach solution is 1.2 grams per centimeters cubed. So one of the things that we could do there, original mass of bleach solution. So the fact they've given us means that we're going to have to use it. So we've got grams over centimeters, or grams per centimeter cubed. We know that our volume is centimeters cubed. If we multiply the volume times the density, the 2 centimeters cubed will cancel out, and we will be left with our mass. So it's going to be 1.2 times 10 equals 12 grams, right? So that was our original mass. And then it says the equations for the reactions in the experiment are. So let's have a think now about what we know and what we need to find out. Now, whenever we get titrations and they give us a description of the method, one of the things to say is that when you're actually doing the calculation, you're always working backwards. So we start with the information that we have at the end, and then we're going back to our original sample. So we have been given sodium thiosulfate. So that's that there. We are having to work out, it says percentage by mass of sodium chlorate. So the first thing we need to know is to work out how much sodium chlorate there is. Now you'll notice it doesn't say sodium chlorate. So what you have got to sort of remember is that if we were to dissolve our sodium chlorate, I should really have that state symbol there, solid, then we would get sodium ions, aqueous, and we would get chlorate ions, aqueous. And if we look at that, we can see that it's a 1-to-1 ratio. So whatever moles of the chlorate ion I work out, it will be the same as the moles of sodium chlorate originally. So, okay, so we've got to get from this point to that point. So we're going to be using this number of moles to work out this number of moles. Now, they're not in the same reaction equation. But something that is in the same reaction, or is in both reaction equations, sorry, is iodine. So you can see that iodine is produced, and then whatever iodine is produced is then reacted with the sodium thiosulfate. So let's just use a color to sort of make that connection. So we've got the iodine here and the iodine there. And the other thing I'm just going to do is I'm going to do the molar ratios. So I know they're pretty obvious, but it doesn't do any harm to really spell these things out. Oops. So the thing is, so what if I do, hopefully what's becoming clearer now is that I can use this to work out this. And then if I know that, I can use that to work out that. So I'm working backwards, which is what you do in any titration, to be honest. So I think we're in a position now to get started. Right, so first things first is, and even if you're totally stuck, you have no clue what to do, in any question you're ever given, if you've got a concentration and a volume of a substance, just work out moles. And you might be able to, that's going to be at least 1 mark. Well, that will be 1 mark, sorry. And then, it may give you a prompt for what to do next with any luck. So I'm going to move this down. I don't know whether you want to take a screenshot or something just so you've got it as a reference for when we're working through the rest of the question. But I might move backwards and forwards. I'll try not to do it too much because actually it'll be just a little bit disorientating. But I think we're now in a position to answer this question. So first things first is we were given the volume and concentration of the sodium thiosulfate, so we can absolutely work out the moles of thiosulfate. And we got given a volume of 33.5 centimeters cubed. Obviously we need to turn that into decimeters cubed. We were given a concentration, and when we do that calculation, we get 3.35 times 10 to the minus 3. So that's the number of moles of the thiosulfate. Now, in the reaction equation, the thiosulfate was reacting with the iodine. So we can do a molar ratio there. So that equals 2 to 1 if we looked back at the reaction equation. Maybe I'll move it down to there. Maybe that's quite helpful for the moment. So therefore, we can work out the moles of iodine. So it is half. It's a 2 to 1 ratio, so half the moles of the thiosulfate. So we're going to get 1.675 times 10 to the minus 3. And then we can now use that number in our first equation. So we can now do a molar ratio of iodine to chlorate ion. And that's 1 to 1. So therefore, the moles of ClO minus in the 25 centimeters cubed. So that's an important thing just to remind yourself. That's why we're doing the y, and the y over 4 was quite important. That equals 1.675. Okay, so that's what it was in our conical flask. However, that conical flask had a quarter of the original moles. So therefore, there are 4 times that 1.675 times 10 to the minus 3 moles in the original sample. So just to be clear, here was when we went through it was our y over 4. So this is going to be our y. So that equals 6.7. Times 10 to the minus 3. So that's moles. Now, we have moles, we have the number of moles of chlorate ions in the original sample. We know that the molar ratio of chlorate ions to sodium chlorate 1 is 1:1. So if we have 6.70 times 10 to the minus 3 moles of chlorate ions, then we have 6.70 times 10 to the minus 3 moles of sodium chlorate. So therefore, we can work out a mass because we can use moles times MR as mass. So mass of NaClO, or sodium chlorate 1, equals our moles times our MR. So we've obviously know what our moles are because it's 6.70 times 10 to the minus 3. And then the MR, use your periodic table, and you work it out to be 74.5. So that equals 0.499 grams. So we now have the mass of sodium chlorate 1 in our original sample. I do have to move this up now. This is where the mass of the bleach sample, this is where we would need to use the density. So the mass of the bleach sample, because they gave it to us as a volume, original bleach sample, I should really write. So that was the volume, and I'll just to sort of show you, centimeters cubed times the density, 1.20, and then grams per centimeter cubed. You can see that they cancel out, so we get a mass. So if you're ever unsure what to do with density, look at the units, see how they cancel out to get what you want. So that's 12 grams. So 0.499 grams was in the original 12 grams, and we're trying to work out a percentage mass. So therefore, our percentage mass equals the mass of sodium chlorate 1 that we worked out was present over the original, or the mass of the original sample, obviously times 100%, and that equals 4.16%, and that is our percentage by mass. That is our answer. If you have any queries about that or anything that isn't clear, please let me know. Otherwise, I hope it makes sense.